So we're going to continue on with this chemical breakdown. Starch is going to simple sugars. Like I started to say, if you would put a Ritz cracker on your tongue, salivary amylase is a type of chemical digestive enzyme that breaks down the starch in that cracker or the carbohydrate in that cracker. So you have a solid and it very quickly turns soggy because of that salivary amylase. Other digestive enzymes break proteins down into smaller amino acids and break fats down into fatty acids. And you have a nice figure for that on page 70 in your text. The mucosa, which would be found in the lining of our mouth, the stomach, the small intestine, those all contain tiny glands that also produce digestive enzymes. So we see digestive enzymes in our stomach and then produced by our pancreas and released into our small intestine to help with that food breakdown. So let's look at the path of digestion then. Like we talked about, the mouth is the first part. And this is where carbohydrate digestion begins. Amylase, which is produced by the salivary glands, helps with that carbohydrate digestion. And then the mouth is also providing us with saliva that helps lubricate that food bolus to make for a smoother transition throughout our GI tract. We have what's called an epiglottis, which is a tiny flap that covers our trachea when we swallow to prevent food from entering our lungs. So if you've ever had food go down the wrong pipe or you've ever choked on milk, that's because your epiglottis didn't close properly, covering your trachea, and that food went into your lungs via your trachea instead of down your esophagus. This is fairly common and fairly benign for most people, but this is a big problem for an elderly population or patients that have neurological difficulties, like someone with MS or Guillain-Barré or that's just had a stroke. Because if this epiglottis isn't covering that trachea because of some detrimental effects of a stroke or from some neurological deficits, chronically that food or those liquids entering the lungs can put them at risk for something um, like a pneumonia caused by those food particles or the liquids in their lungs. It's called aspiration pneumonia. So as the food moves from our mouth, the epiglottis covers the trachea, it goes down the esophagus, and the esophagus is about 10 inches long. And this is where we're really going to start to see the waves of muscle contraction called peristalsis. And we move into the stomach. We see the stomach muscle doing contractions in many different ways. So it's not just one direction of muscular contractions. We're having the stomach contract from top to bottom, from side to side, from bottom to top, and from the other side to side. And what that's going to do is churn food up into this liquid consistency. Once that food is churned up, it's called chyme. Our stomach can hold about a liter of food, and an enzyme called pepsin will start the protein breakdown in our stomach. Okay, starch digestion stops in our stomach, and that'll carry on a little later. But the high acidity from hydrochloric acid in our stomach allows calcium and iron to be absorbed, and that stomach will hold that liter of food for about 2 to 6 hours at the most. Okay, if we have a higher fat meal, that fat stays with our system longer and it takes longer to empty, so we'll be on the higher end of that process. Because of the mucosal secretions in the stomach, it's actually protected from eating itself away. So that high acidity of the hydrochloric acid in the stomach, that's working on breaking down food, but it's not breaking down our stomach lining because of that mucosal secretion. And then we move from the stomach to the small intestine, but I'm going to stop there.